Hi, CAD II. I hope things are going well for you. I'm having some technical difficulties over here, but I'm going to voice over the lecture I recorded yesterday. So it might sound a little bit different, but it might allow me to organize my thoughts a little bit more. So we will see how that goes. Basically, we're going to talk about grading. So you probably know that grading allows us to make clothes larger or smaller than the original pattern size. The master pattern size is your original pattern size. So I'm going to first talk over some basic Euclidean geometry and kind of how we're going to add and subtract x and y coordinates in order to plot the grading or the size of the garments. And then we're going to jump into how to do the worksheets. I understand if you guys need more time on this worksheet because I feel like I'm now so late with this lecture. So definitely let me know. All right. The Euclidean graph or Euclidean geometry is the most basic type of geometry. The x-axis is the horizontal axis of the graph, and the y-axis is the vertical axis of the graph. The top or movement going upwards is actually y, positive y, and movement going downwards is actually negative y, and movement going to the left is negative x, and movement going to the right is positive x. So we are going to be using this to move around the page. Remember, the origin is actually 0, 0. That is how the coordinates are written. The coordinates go x, comma, y. I do think I'll get to that in a second here. Um, I'm just establishing the x and y axes on this square grid, and we're kind of turning it into the Euclidean geometric plane. And again, downwards is negative y, and to the left is negative x. The coordinates are written x, comma, y, and we can use this to plot points on the graph. Each of the tick marks on the axes equals 1 in this example, and we can also tell what direction something is going to be moving in based on the coordinates. So if something has both x and y positive, it'll be moving to the upper right quadrant. If something has x and then a negative y, it'll be moving to the lower right quadrant. Both negative x and negative y, lower left quadrant, and negative x, y will be the upper left quadrant. And we can use this in order to establish where the key grade rule points of the garments will move around. We're going to have to use math in order to move them in specific directions. So we are going to plot a few points here as an example. That point is 2 in the x direction. I miscounted it as 3, but it's actually wrong because you do not count the origin. So it's 2, comma 1 is how you would plot that point. And then I started writing the numbers so I wouldn't make that mistake again. 2, comma 1. And we are going to use Euclidean geometry or the Euclidean coordinates in order to move that point around the page, essentially. So if it is going to get moved, is that what we're doing? Yeah, if it is going to get moved 3 over in the x direction and 2 up, this is how it would be moved, right? So you're essentially adding those numbers together. So 2 plus 3 equals 5, and 1 plus 2 equals 3, and so that is actually the next coordinates would be 5, comma 3 of that new point. But we mostly just use the movement coordinates. They're kind of acting like vectors in this worksheet. We're mostly just adding together um, the we're mostly just defining the movement coordinates. So now I'm making another example where we're going to move down and to the left instead of up and to the right. Both of the movement coordinates when we moved up and to the right were positive, and both of these movement coordinates are going to be negative. So we're going to move the 6, 7 coordinates to 1, 5. But really we're more interested in kind of the vector, or what I've been calling the movement coordinate, to get it there. So I actually get these numbers backwards right here. I do -2, -5, but when I go to add them up, they don't equal 1, 5. So I realize I've made a mistake in this simple math. So I I rethink my math here, and my movement coordinate is actually -5, -2, because the horizontal movement comes before the x coordinate, y coordinate always. And I just got them backwards. So now I'm counting again, and this is going to be -5 because it's moving to the left, and -2 because it's moving downwards. And now if we add those two numbers up, they do actually equal the proper coordinates 1, 5. Right? So all of the movement coordinates are additive to the original coordinates. So that's why we have to mark them with negative and positive, because we are always going to be adding them to the final coordinates. So if it's actually less than or if it's actually getting like moving to the left, or if it actually does need to get smaller, then some of the coordinates have to be negative. So I've handed out your worksheet, and I'm focusing on page 45, I believe. Page 44 is actually what has the different types of grade rules on it, and I'm only going to have you look at the 1.5-inch grade rule, which is used for sizes 10 to 16 in order to grade those sizes. We're going to leave off the smaller and larger sizes, which use different grade rules, just to make things easier, because we're just learning about this concept at this point. So the 1.5-inch grade rule is the center one, and it's only used for this gray section in your worksheet. And it says right under notes that the 1.5-inch grade is used for 10 to 12, 12 to 14, and 14 to 16. Um, that that understanding that grade rule will hopefully allow us to understand all the other grade rules without going crazy. So essentially we are developing the coordinates that could be used to plot the different grading points of these garments. And if we had Gerber, these points would be put into the garment. So I don't think that having those grade rules vertically is that helpful. So what I'm doing is I'm writing down all the numbers just bigger so I can see them without having to squint at the page. And then I'm going to actually rotate this 90 degrees, rotate the bodice front, because the bodice front on our concepts of pattern grading worksheet is oriented with the center front waist at the origin point. Uh, Rule number 1, you can see it's already filled in all with zeros, and that is because the center front waist does not move at all during this grading. All of the other points are going to get shifted bigger or smaller away from or towards the origin point, but not um, not rule 1. Rule 2 also has a 4 in size 14, and I've never been sure why it did this. Maybe it's just that I don't actually have a full understanding of what this worksheet says, but I've never found that 4 out to actually be accurate. If you guys read the worksheet and you understand that I'm actually doing this totally wrong, let me know. But this is how I understand how to do the worksheet. So I'm actually going to erase the 4 here eventually once I get tired of starting to write around it. Is that what I'm doing now? No, I'm choosing a color that will show up better than black on this worksheet. And I work in this green for a while and then I switch to red. So like I said, point 1 is the origin point, and we have zeros filled in for that whole column because it doesn't move. Everything shifts away from it or towards it, depending on whether the sizes are getting larger or smaller. So the first rule we have to do is actually rule 2, which is only going to shift upwards. There is only one horizontal slash line between each of the between the 2 and the 1, and we are going to fill in rule 2 based on where it lies in the slash lines. The slash lines are labeled on either side. So that first horizontal slash line, and see I finally fixed it so it's horizontal, is labeled 1/8 on one side and 1/16 on the other side. And I believe I'll write those numbers there eventually. We are going to focus on the side that says 1/8, and that is actually going to be our movement in the vertical direction, in the Y column direction. Excuse me if I ever get X and Y mixed up, which I know I do at least once in this section, but I think I fix it pretty quick. So yeah, like I'm saying, we're going to ignore the 1/16 side and we're just going to use the 1/8 measurement. So basically on all of those slash lines, they would be cut and then moved apart 1/8 of an inch for, or whatever their measurements label is, 1/8 of an inch for each section. So the X number in rule 2 is actually going to be 0 the whole column. So we can type in zeros from 6 to 22 actually, because it is not moving to the right at all. There are no vertical slash lines between it and the vertical axes, so it's not moving to the right at all. So here I start getting frustrated with that number 4. But hopefully the slash lines make sense. Basically, for rule 2, we are just going to, it only has one slash line between it and the horizontal axes, so that's the only slash line we have to worry about. And the math is pretty easy. It's just going to, for larger sizes, get moved up 1/8 of an inch. And for smaller sizes, it's going to get moved down 1/8 of an inch. And the whole dart is labeled rule 2 because it's all in the that kind of quadrant between the slash lines, right? So the Y column, we start labeling positive 1/8 of an inch for 14 because it would get 1/8 of an inch bigger at that point. And I believe that this is where I erase 4 really quick. yeah, and we do 1/8 of an inch positive, and then I decide I need to do it in red, because it really isn't showing up well in the green. Here we go. So positive 1/8 of an inch for size 14 and negative 1/8 of an inch for size 10, because size 10 would be moving towards the origin point or moving downwards, negative 1/8 of an inch, or yeah, a whole 1/8 of an inch. And then we actually type in the same number for the upper, for the size above size 14. We're doing this in a cumulative fashion, so you don't actually need to add those numbers together. It's just saying that between 12 and 14, it's going to move 1/8 of an inch, and between 14 and 16, it's also going to move 1/8 of an inch. So for size 14 and 16 are pretty much always going to have the same numbers in them, and then size 10 is going to be probably the negative version of that number. So zeros in all of the x columns and negative 1/8 for smaller sizes, positive 1/8 for larger sizes for rule 2. Hopefully that makes sense. And rule 3 just involves a little bit more math. There's still the first slash line that will move it up 1/8 of an inch, but then there are now 2 other slash lines that are going to move it upwards, between it and the horizontal axes, right? All of the horizontal slash lines are going to move it upwards. So I transfer those numbers, I believe. The vertical slash lines are still not affecting this. It's not going to move to the left or right at all. So actually we can say for sure that the x column is still going to be 0 all the way, because this is on the y-axis. So the x column has to be 0. And it stays on the y-axis even in these movements. So 1/8 for that one, it's going to move 1/8 and then 1/16 and 3/16. And those numbers all get added together in order to find the movement coordinates, or like the movement vector of rule 3. So 1/8 is 2/16, add them all together, 6/16, reduce that, 3/8. And please excuse me if you notice that any of my math is wrong in this. Doing simple math is something that I have always struggled with, but I do think, I've always been pretty good at fractions, but forgive any simple mistakes. So for the larger sizes, it's going to get moved upwards, so those are positive numbers. And for the smaller sizes, it is going to be negative 3/8, because it would be moving downwards or closer to the origin point in order to get smaller. And then the x column is all zeros again. It doesn't move to the left or right at all. The x column defines the left and right. Rule 4 is going to be our first rule that does move to the left and right. I'm just deleting all of the other work I've done in order to focus on rule 4. And it is affected by both the horizontal and vertical slash lines. There are horizontal and vertical slash lines between it and the origin point or the axes. So it is definitely moving. It's only affected by this one vertical slash line, so that is the only moment that is going to affect its x movement, its left and right movement. So it's going to be moving 1/8 in the x direction. It'll be moving -1/8 for the smaller sizes because it'll be moving to the left, and it'll be moving +1/8 for the larger sizes because it'll be getting larger by moving away from the axes to the right. Because this is the first one where we have a number that's not 0. This is our first movement that is going to be properly towards the upper right quadrant, the positive x, positive y quadrant that I was discussing. Oh, so I actually drew those in the wrong column, classically. Those are our x coordinates, 1/8 inch for the smaller numbers, -1/8 inch for the smaller sizes, and +1/8 inch for the larger sizes. And the y coordinate is also going to be positive for the larger sizes, which will move it up and to the right. So now I'm just writing down all of the different coordinates. Some of the lines end in different numbers depending on whether they're on the left or the right. So I'm starting to think that this is more towards the 1/16 side of this bottom line, and that the middle line, we're starting to get towards more the 1/8 of the side of the horizontal middle line. So those are the numbers I end up adding together, 1/16, 1/8, and 3/16 in order to get its y movement. So I know that's kind of fuzzy because it would be some kind of in-between number in the middle there of some of those lines with different numbers on either end, but it's your grade rule, so as long as you are confident, you should just pick the side that it's closest to. So I am adding up all those numbers and getting 6/16 again. So we are at 3/8 again. So for the y coordinates, for the larger sizes, we want it to move up to the right, so positive x, positive y, positive 3/8. And for the smaller size, -3/8. A negative x and a negative y means it would move down to the left. I just drew the coordinate for the positive x and the positive y, or the movement for the positive x and the positive y, and then the negative x and the negative y would be moving down to the left. Rule 5 is the armhole notch. It has similar coordinates to Rule 4, especially in its left and right movement. It still only has that first vertical slash line between it and the y-axis, so it is going to have the same 1/8 movement as Rule 4 in the x column. So that's, I think the first thing I write down here is, yeah, -1/8 in the x column and negative or positive 1/8 in the x column for the larger sizes. For y, we need to add together only 2 of the slash lines that we've seen. We need to add together 1/8 and 1/16 because those two lower slash lines, lower horizontal slash lines, are the only slash lines between this point and the horizontal axes, so they're the only ones that affect this point. So we add together 1/8 and 1/16, and we get 3/16. Negative, that should be a -3/16 up there, and then positive 3/16 in the lower columns. Rule 6 is going to have the same y coordinates as Rule 5 because there is still only those two horizontal slash lines between it and the axes. So we know that Rule 6 is going to be moved 3/8, either negative or positive, depending on whether it's getting larger or smaller. I mean 3/16. And in the x direction, this is the first one that has two slash lines between it and the vertical axis, two vertical slash lines between it and the y-axis. So we are going to have to add together both of those slash lines, and I believe I transfer the numbers here in a second. It's 1/8 again. And then up there, I guess it's also 1/8. So that's nice and easy. We can just add 1/8 on both sides, keep it simple. So 1/8 plus 1/8 equals 1/4. So in the x column, that point is going to move a full 1/4 inch, which makes sense. That point should be moving the most because it is the furthest away from the axes, right? If we just added 1 inch to one point when trying to make this grade, things would get real wonky real fast in our pattern, which is why we have to add 1 inch slowly across the pattern and across the front and back. So there's a tiny slash line that doesn't go all the way to the other side, where number 7 is also going to get moved 1/16 of an inch out. So if we add 1/8 plus 1/8 plus 1/16, we will get its y or its x movements, its horizontal movements. And 1/16 is also the measurement for that side of the slash line there. So its y coordinate, it's only going to get moved up 1/16 because it only has one slash line in between it and the center front or the horizontal axes. And for its x movement, we have to add together 1/16 and 1/8 and 1/8. Which equals what, 5/16. So negative 5/16 in the smaller sizes and positive 5/16 in the larger sizes. So we're on to the last grade rule here, rule number 8. And rule number 8 is on an axis, so it is on the x-axis in this case, and it has no slash lines between it and the x-axis, so it is not going to get moved vertically at all. So all of the numbers in the y column should be 0. The y is its vertical movement, it's not getting moved, it's staying on the slash line, and it is going to get moved 1/4 inch to the right. Up and down, 0 in all of the columns, or in all of the rows. Up and down, 1/16, or sorry, 1/4 of an inch. Negative 1/4 of an inch for size 10, positive 1/4 of an inch for size 14 and 16. And with that, we have completed the grade rules for the bodice here, for the front bodice. And this bodice is very consistent. It has all negative x, negative y for the numbers smaller than the master size of 12. And it has all positive x and positive y for the sizes larger than the master size of 12. The negative x and negative y are moving it down, are moving all the points down and to the left, and the the positive x and the positive y for sizes 14 and 16 are moving all of the points up and to the right. So the garment is getting bigger. For some, so this one is very standard, and so is the bodice back. It's the same kind of layout, but some of the garments are going to be a little bit more complicated. They won't all be centered in the upper right-hand quadrant. They will maybe be centered in the upper left-hand quadrant or centered in all of the quadrants. I do bring in an example of that here in a second, just to address it. Hopefully this is making sense, and hopefully my math is correct here. I'm just opening up your worksheet, and we're going to talk about, really quick, talk about one of the other sizes, right? Or one of the other pieces of your sloper. Again, this one is pretty standard all the way across, but you might have to use your brain and your knowledge of basic geometry in order to do the grading appropriately. They're all pretty much laid out this way. I still don't know why there's a 4 there, but that's probably just my misunderstanding of how the worksheet teaches grading besides like how I was taught to do grading at some point. So let me know if you figure that out. So there's the bodice back. It also gives you the 3 grades and all the slashes in the front. And this is going to be the same with -x and -y for the smaller sizes. The sleeve is the first one that seems pretty unusual. It has the kind of center of the sleeve on the origin point. So you're going to have to think more about your numbers here. And I actually bring the image in here in a second, but basically, if your number is, if your coordinate is in the lower left-hand corner, and you want it to get bigger, it is going to have to, you're going to have to use the correct numbers. So here it is, we've copied and pasted into the document here, so we can look at both of these things at the same time. But if that point was getting smaller, you would need to use, or if it was getting larger, you need to use -x and -y, and if it was getting smaller, they would need to be +x and +y. So this would actually be the opposite of the bodice that we just did, right? And this should kind of make sense in terms of the movement coordinates, the direction that things are moving. So for this coordinates, it would be -x and y and +y to move it bigger and away from the origin and the axes. And then if it's getting smaller, it would be doing +x and -y. So the opposite would be true in the other quadrants, right? If your point is in the lower right-hand quadrants, things getting smaller are going to be -x, y, and things that are getting bigger are going to be x, -y. So you just need to use your logic in order to make sure that things are actually just moving the way you expect them to move. It's as long as you're like getting your math correct and you're adding up all your numbers, it's easy enough, all of your numbers correctly, it's easy enough to plot out these points and kind of check if things are getting larger or smaller. And then just like flip the negative and the positive to the other side, and kind of check that way. Just think about it logically, which way is negative and which way is positive. The sleeve is probably the most complex one. The skirt takes place all in the upper left-hand quadrant, so it'll be consistent which side should be negative. And I think the pants might be a little bit more complex here. Um, but it all should be broken down in this worksheet. So let me know how it goes. I'm just talking over my outro here, but please let me know if you have any questions, okay? Bye!